Welcome to Ask and Learn.
In this problem, we have one part of an insulated tank which contains compressed liquid, while the other side is evacuated. The partition is then removed, and the water is allowed to expand into the entire tank. We wish to determine the final temperature and the volume of the tank. We assume that the tank is stationary, and thus kinetic and potential energy are zero. The tank is insulated and heat transfer is also negligible, and there are no work interactions. So we take the entire contents of the tank as the system, and we can write the energy balance equation of this system. Since there's no volume change and there's no boundary work, we can write the energy balance equation E in minus E out is equal to delta E system. Now, there's no net energy transfer by heat, work, and mass. So the left-hand side is zero. And we have a change in internal energy, delta U. And this is equal to M into the specific internal energies, little u2 minus little u1. Remember, W, Q, kinetic energy, and potential energy are all zero here. So we can see simply that the internal energy per unit mass in state 1 is equal to the internal energy per unit mass in state 2. So that's our energy balance equation. Now, using our tables, we can find the properties of the water. So the initial pressure, P1, is 600 kilopascals, and the temperature is 60 degrees Celsius. So going to our tables, this corresponds to a specific volume V1, which is Vf at 60 degrees Celsius, and this is 0.001017 cubic meter per kg. So from our tables, that's our specific volume in state 1. The internal energy, U1, is also equal to UF at 60 degrees, and this is 251.16 kilojoules per kg. We now assume the final state in the tank is saturated liquid vapor mixture, and we can determine the quality. So the assumption will be verified if you get a quality between 0 and 1. The pressure is 10 kilopascals, P2, and U2, remember, is equal to U1. So if we use U1 from above, we find that Vf is equal to 0.001010. Remember, it's a mixture, liquid vapor mixture. So Vg is 14.670. These are in SI units. Uf is equal to 191.79. These are the internal energies. And Ufg is equal to 2245.4. That's kilojoules per kg. So V is measured in cubic meters per kg and U in kilojoules per kg. Now, our quality of the mixture, X2, is equal to U2 minus Uf over Ufg. So this is 251.16 minus 191.79 all over Ufg, which is 2245.4. And so we get our quality to be 0.02644, which is roughly 2.6%. And so therefore we can find T2, the temperature of the second state of the system to be the saturated vapor temperature at a pressure of 10 kilopascals. So we go back to our tables here and we get this temperature to be 45.81 degrees Celsius. So that's the temperature that we require. Now to find the volume, we first need to find the specific volume V2. So V2 is equal to Vf plus X2 VFG. So we found the quantity, we can now find the specific volume. So this is 0.001010 plus X2, which is 0.02644 multiplied by VFG, which is 14.670 Vg minus Vf, which is 0.001010. And these are in units of cubic meter per kg. And so we get V2 to be 0.38886 cubic meters per kg. And therefore, we can calculate the total volume. V is simply the mass times the volume per unit mass, V2. And so this is the mass of water, 2.5 kgs into 0.3886 cubic meters per kg. Hence we get the volume of the final system to be 0.972 cubic meters.